graduate of Master of Science in Chemistry from the University of Santo Tomas. She is an instructor in the Department of Chemistry at the University of Santo Tomas. Her presentation is entitled Antiproliferative and Cytotoxic Cytochalasins from Sparticola. Okay, it's a very difficult and aggregation. So let's all welcome Miss Katherine.
So cancer is a complex disease that is characterized in proliferation of abnormal cells in our body, which could interfere with cell cycle function. And unfortunately, at present, the most common cancer treatment includes radiotherapy, surgery, and chemotherapy. However, all of these are associated with side effects. Now, chemotherapy drugs work by interfering with the way cancer cells make important molecules like DNA, RNA, and proteins. DNA damage, DNA alkylation, cell cycle inhibition, or angiogenesis inhibition, or by causing the cancer cells to undergo apoptosis or self-destruction. In addition, microtubule inhibitors such as vinca alkaloids and taxanes are like the superheroes against cancers. They work as disrupting the cell cycle division, which causes cell cycle arrest and induce apoptosis. However, those inhibitors, the current chemotherapy drug inhibitors, are not very precise in targeting cancer cells. So how do we solve these problems? So this is the contribution of my work. We explore the underexplored mechanisms of cancer, which is microfilament disruption. And good afternoon to everyone. I am Katherine Yasmin and Garcia, and I'm very pleased to present my study entitled Antiproliferative have revolutionized the field of drug discovery by yielding potential drug leads. And among this, potential drug leads, specifically the partially exploited dothiomiacetes, which is an excellent source of finding a new generation treatment. And a common example is paclitaxel, which is an FDA anti-neoplastic agent, followed by wertmanine and PX866, which is currently undergoing phase 2 clinical trials. And from our previous reports, we also isolated several spironolidinoxynaphthalene derivatives that have shown cytotoxic potential. And although chemotherapy drugs have made progress over the years, there's still a demand for a targeted and potent chemotherapeutic agents. In this study, we aim to explore the chemical constituents of Sparticola triseptata that is present in the solid rice fermentation culture. The compounds were then subjected to different cytotoxic and antiproliferative effects against different cancer cell lines. And in addition, to further understand the mechanism of action, we studied the effect of on actin filament. So the experiment started by cultivating the fungi in a nutrient agar, followed by large-scale fermentation in solid brown rice media. Then it was subjected to ethyl acetate extraction, homogenization, and defatting. So the combined organic layer was then concentrated to obtain a crude extract, which was then subjected to chemical screening. And using several staining reagents, we detected the various compounds that are present, which are triterpenes, sterols, phenolics, and coumarines, among others. And this was further substantiated by the LCMS chromatogram as presented in this slide. The purifications were done using iterative gravity column and HPLC. The isolated compounds were polarization experiments and spectroscopic analysis. And in vitro assays were also performed to evaluate the biological activity of the isolate. Right. So a total of 5 secondary metabolites were isolated. Among these is a new cytocalasin analog referred to as triseptatin. And we also identified 2 cytocalasin derivatives, namely the oxaphomine B and cytocalasin B. And we also identified 2 isocoumarine derivatives. So presented in this slide is the various results from our experiment, which help us to characterize the molecular structure of the compound. Figure out how atoms are arranged in a molecule. And To do this, no, there are several methods, like we analyze the NOSI spectrum and we perform ECD calculations. So just like how we connect the dots in a picture to reveal its shape, the NOSI spectrum tells us how the different protons are arranged relatively with one another. So from our analysis, the proton sets in the red font are oriented similarly, and the proton sets in the blue fonts are oriented in the opposite direction. And after that, we perform a computational analysis called electronic circular dichroism technique. So we identify these two low energy conformers, and then after that, we generate a theoretical ECD spectrum. So the theoretical ECD spectrum is the one that is represented by the red. Overall molecular structure of all of these compounds, we need to solve a puzzle. And that puzzle is a result of the one-dimensional and two-dimensional NMR spectroscopic data. So here is the result. We identified the triseptatin as a novel acetylated cytokalasin. And given in here are the different structures of the isolates that were obtained, and they were isolated using the similar technique as what we have done in this triseptatin cytokalasin derivative. Alright. Now, may ring, ano ba tong cytokalasin na to? No? Hindi namin alam kung ano ito. Pero itong cytokalasin na to, these are group of fungal metabolites that were discovered and isolated way back in 1950s. And these cytochalasins have a very diverse structures as presented in here because of their intermolecular rearrangement and Fourier substitution patterns. Now, these cytochalasins are very important class of compounds because they exhibit a wide range of bioactivity. And in B and D, target cytoskeletal destabilization. So our research group hypothesizes the following: groups be accountable for their observed bioactivity that could potentially disrupt essential cellular pathways and offering a promising avenue for novel cancer therapy. So now to answer this one, let us now go on to the most exciting part of our research work, which is the evaluation of biological assays. So we have here, we use colorimetric assays to evaluate the effect of the compounds in cell viability and proliferation. And from here, the results will be expressed as IC50 and GI50 values. So these IC50 and GI50 values will tell us what concentration will inhibition of the biochemical will be reduced by 50%. So ang target natin dito is to get a low IC50 values and GI50 values, which indicates high effectivity and potency. Now let's take a look at the results of our experiment. So the cytochalasins 1 and 2 have shown high potency as evidenced by their low IC50 values, indicating that these cytochalasins are effective in inhibiting cancer cell growth at low concentration. And although cytochalasins 1 and 2 are less potent than the epithelome B, by examining these IC50 values, we can say that the isolated chalasins are shown to be 3 to 4 times more effective in targeting cancer cell lines, which means particularly in cervical, breast cancer, ovarian, and skin cancer cell lines. Alright? And then, in addition, these cytochalasins also displayed a moderate anti-leukemic activity and a strong antiproliferative effects as displayed in this table. So which means that when the GI50 values are lower in the normal cell lines than the leukemia cell lines, it means that the isolated compounds has more inhibitory effect in the cancer cell line. So thus, from all of the results of our bioactivity, we can say that the isolated cytochalasins prefer to eliminate the cancer cells over the normal healthy cells. Okay. We can say that cytochalasins 1 to 3 at very low concentrations. Can you go back po? Yeah. So this is the actin disruption assay results. We use fluorescence microscopy. So as here showed the isolated cytokalasin, and in the row showed the dose concentrations of the compound. So as presented in here, at very low concentration, it showed the presence of aggregates and strongly contrasted cable-like remnants. That the actin filament starts to disintegrate. And this is more evident at high concentration because, as you can see, all of the actin filaments are now totally disintegrated in this picture. And after 1 hour, we perform washout experiment to determine its mechanism of action. So, as you can see in the slide, the actin filaments reverts back to its original form, which means that the mode of action is reversible actin disruption. Back, the discovery, mechanism of action, toxicity, and biological function. We have also established the potential.
Welcome, Dr. Bryan John A. Magoling.